Case study, Implementing AI in Cybersecurity, a case study on enhancing incident response at Technova. Cybersecurity is undergoing a paradigm shift with the integration of artificial intelligence. Consider a typical day at Technova, a medium-sized technology firm with a growing concern over its cybersecurity posture. The team, led by Chief Information Security Officer Elena Martinez, is facing an ever-increasing volume of cyber threats. The manual processes historically employed for incident response are proving inadequate, leading to slower reaction times and heightened risk exposure. The challenge at Technova is clear. The sheer volume and complexity of modern cyber attacks demand a more efficient and effective solution. Traditional methods involve significant manual intervention, from analyzing logs to identifying potential threats and formulating a response. But what if these processes could be automated and enhanced using AI? Martinez's team recently experienced a security breach that highlighted the limitations of their current approach. The breach began with a seemingly innocuous phishing email that slipped past their traditional email filters. The email was part of a targeted spear phishing campaign that led to the compromise of a senior executive's credentials. Once inside the network, the attackers moved laterally, exfiltrating sensitive data before Technova could effectively contain the threat. This incident sparked a series of questions among the team. How could they have detected the phishing email sooner? What if an automated system had been in place to analyze and respond to such threats in real time? What role could AI play in preventing future breaches? To address these concerns, Martinez initiated the deployment of an AI-driven security information and event management system. This system, powered by machine learning and natural language processing, promised to revolutionize their approach to incident response. One of the first tasks for the AI system was to monitor network traffic continuously, identifying patterns and anomalies that might indicate a potential attack. Within weeks, the AI system flagged unusual network activity that human analysts might have missed. It detected an anomaly in network traffic consistent with a distributed denial-of-service attack. The AI's ability to analyze vast amounts of data in real time allowed it to identify this threat almost instantaneously. The team was notified, and the AI system automatically initiated predefined response actions to mitigate the attack. This proactive detection and response raised another critical question. How does AI improve the speed and efficiency of incident response compared to traditional methods? The answer lay in the AI's capability to process and analyze data at speeds unmatched by human analysts. By correlating events from diverse sources and prioritizing alerts based on threat severity, the AI system reduced the response time significantly. However, the integration of AI was not without its challenges. The team had to ensure the AI models were trained on high-quality representative datasets. What if the training data contained biases or inaccuracies? Martinez knew that AI's effectiveness depended on the reliability of the data it was trained on. She mandated continuous updates to the AI models to keep pace with the evolving threat landscape, thus minimizing the risk of false positives or negatives. Furthermore, the team faced the potential threat of adversarial attacks where malicious actors might manipulate AI systems. What measures could they take to protect their AI-driven systems from such manipulation? They implemented robust defense mechanisms, including anomaly detection algorithms designed to identify data poisoning attempts and adversarial examples. Despite these challenges, the AI system's benefits were becoming more apparent. For instance, it significantly improved the accuracy of incident analysis. Using natural language processing, the AI could scrutinize unstructured data, such as emails and chat logs, for indicators of compromise. This capability was particularly useful in identifying phishing attacks. The system could examine the content and context of emails, detecting malicious intent that traditional filters might overlook. Another advantage was in post-incident analysis. Following the initial breach, the AI-driven forensic tools helped reconstruct the attack timeline, identifying compromised systems and suggesting remediation measures. This level of insight was invaluable for understanding how the attack was carried out and what vulnerabilities were exploited, leading to better preventive measures in the future. The AI's role extended to threat intelligence gathering. By scanning dark web forums and other sources, the AI identified emerging threats and vulnerabilities. This proactive approach allowed Technova to stay ahead of potential threats, bolstering their overall cybersecurity posture. The case of Technova raises several thought-provoking questions. How can organizations ensure the quality and reliability of the data used to train AI models? What strategies can be employed to defend against adversarial attacks on AI systems? How does AI's ability to analyze unstructured data enhance threat detection and incident analysis? The answers lie in continuous improvement and vigilance. Ensuring data quality involves rigorous data collection protocols and regular updates to training datasets. Defending against adversarial attacks requires robust anomaly detection algorithms and constant monitoring for signs of manipulation. AI's ability to analyze unstructured data enhances threat detection by providing deeper insights into potential threats, improving the accuracy and efficiency of incident response. Technova's experience also underscores the importance of a proactive approach to cybersecurity. Traditional methods often rely on reactive measures, addressing threats only after they have been detected. In contrast, AI enables predictive analytics, identifying and mitigating potential threats before they can cause harm. For example, AI systems can analyze patterns of behavior and predict potential insider threats based on anomalous activities, enabling organizations to take preventive measures. Additionally, continuous monitoring and threat hunting are critical components of a proactive cybersecurity strategy. AI-powered tools can automate these tasks, scanning vast amounts of data and identifying subtle indicators of malicious activity that human analysts might miss. This approach not only reduces the likelihood of successful attacks, but also minimizes the dwell time of threats within the network. In conclusion, the application of AI for automation in incident response represents a significant advancement in cybersecurity. By enhancing threat detection, reducing response times, improving accuracy, and enabling proactive measures, AI technologies provide organizations with powerful tools to combat the increasing complexity and volume of cyber attacks. While challenges such as data quality and adversarial attacks must be addressed, the benefits of AI in incident response are substantial and far-reaching. As AI continues to evolve, its role in enhancing cybersecurity and protecting critical assets will only become more pronounced.